Hello and welcome. Today we are going over compound inequalities. So recently we've been dealing with solving just basic inequalities, such as p minus 4 is less than or equal to 6. And to solve this, all we're going to do is we want to isolate the variable. So we are going to use those inverse operations. Whatever I do to one side, I must do to the other side. So I'm left with p is less than or equal to 10. So this tells me all of the values that p can be. It's anything less than or equal to 10. If I just throw that on a number line really quickly, I shade it in because it's less than or equal to, and everything to the left of that is a solution. So if you were to plug in 3 minus 4 is negative 1, yep, that's less than or equal to 6. So that is a solution. All right, so here in this compound inequality, now we have more than one inequality. Here we can see we have two inequality signs. We know that p minus 4 is greater than or equal to negative 6, and we also know that it's less than 2. So that's what makes it a compound inequality, is there's more than just one inequality sign now. Well, we're going to solve this really the same exact way, the same way we would solve the other inequalities. I want to add 4, right? I want to isolate this variable p. So I'm going to add 4. Just like before, whenever I did to one side, I had to do it the other side. Here, whatever I do to the middle piece, or whatever I do to one piece, guess what? You need to do to all of them. So if I'm adding 4 to this middle piece here, I'm going to add 4 to the left piece and add 4 to the right piece. Here, that just cancels out. I'm just going to be left with p. And then negative 6 plus 4 gives me negative 2. The sign is going to stay the same. And then 2 plus 4 gives me 6. So I know that p is going to be greater than or equal to negative 2 and less than 6 in this case. So greater than or equal to negative 2 and less than 6. So if we want to throw this on a number line, let's just say negative 2 is right here, and that's going to be filled in, and 6 is over here. Well, everything in between those is a solution, such as 0. If we were to plug in 0, 0 minus 4, that's negative 4. Yep, that's greater than or equal to negative 6, and yes, that's less than 2. So that works for this compound inequality. Another way we might see this written is it's separated and we have the word and. So with this word and, we know that it must satisfy both of these. Just like in this last one, we needed to be greater than or equal to negative 6 and we needed to be less than 2. Well, in this one, again, we're going to need to satisfy both. So let's solve each of these separately for a. To do that, I'm going to start by adding 4 here. I add 4 to both sides. I'm left with a is greater than or equal to 1. And over here, I'm going to multiply by 2. So I multiply by 2 times 2 times 2. And I get a is less than 10. So a is greater than or equal to 1. And a is less than 10. Well, if we were to throw this on a number line, I'm looking for where the two of these intersect. I'm actually going to write this in green. A is less than 10. So I'm looking for where the two of these intersect. If I graph a is greater than or equal to 1, let's say 1 is here, it's filled in, and then I graph everything to the right of it. Well, a is less than 10. Let's say 10 is right here. I have an open circle. And then I graph everything to the left because it's a less than sign. Well, we are looking for where it overlaps. So on the number line, it's going to overlap right in here from 1 to 10. And again, we could actually write this the same way we saw this last inequality, right? I know that I could put my a here, and I know a is greater than or equal to 1. So I say, all right, well, it's greater than or equal to 1, but it also has to be less than 10. It needs to satisfy both of them. So it's where the two intersect. And we can clearly see where they intersect from this black box. So even if you struggle writing this up here, graph them both on a number line and see what is their intersection. Whenever it says and, we're looking for the intersection of the two because it must satisfy both. All right. On the other hand now, here we have the word or. Okay, so either this could be true or this could be true. Either one could be true in this case. So we are just going to graph both, and then both lines are going to be our solution. Okay, both of those lines on the number line will be our solution. So let's start off over here. I'm going to divide by 6, and I get b is less than or equal to a -4. On the right, I'm going to subtract these by 3, and I wind up with b is greater than 2. So now I am either less than or equal to -4, or I'm greater than 2. Let's throw each of those on the number line. -4, 2. Well, greater than 2 is just going to be an open circle and to the right. And then for b is less than or equal to -4, it's a filled in circle and everything to the left. And again, both of these are solutions. So this is my full solution right here. B is less than or equal to -4, or b is greater than 2. And it's written exactly like that. And then on a number line, here's my solution graphed. All right, so with or, it's both lines. It's not the intersection. It's just, well, it could be this line or it could be this line. And finally, let's take a look at one more compound inequality here. The reason I'm showing this compound inequality is because when I have to solve for b here, I'm going to have to divide by a negative. And we know when we divide by a negative, we had to switch signs before. Well, let's see if that still holds up. Here, I divide every piece by -4. I'm left with 1 is less than or equal to b is less than or equal to -4. Okay, here I did not switch signs yet. And clearly, well, does this make any sense, right? How could b be greater than, how could b be greater than or equal to 1 and also less than or equal to -4? Right? That doesn't make any sense. It's impossible for b to fall between, it's impossible for it to fall to the left of -4 and to the right of 1. Okay, so again, we need to switch the signs in this case. If we switch the signs, we would write it as, well, b is greater than, b is less than or equal to 1 and greater than or equal to -4. My apologies on some of those slip-ups. So -4 is here, 1 is here, and we are just going to be between the two of them. Okay, so this here is our correct answer. Up here, and again, make sure you continue to flip the sign.